Hello, welcome to another Eighth Wall live learning session. This webinar series is where we invite our developer community to come join us for an interactive session of tips and tricks related to WebAR development. If this is your first time here, welcome. If this isn't, welcome back. If you have any questions during the webinar today, please use the Zoom Q&A window. This session is being recorded and it will be posted to both YouTube and our website afterwards. We'll also have time for Q&A live at the end of today's webinar. Before we begin, let's do a couple of introductions. Once again, my name is Tony Tamarchio, and I'm the Director of Technical Operations here at Eighth Wall. And as always, I'm joined by Rigel Benton, our lead product designer. Many of you have probably seen us on our developer Slack channel, but if you aren't a member already, please go to eighthwall.com/Slack and sign up. We're at over 4,300 members now, and it's a really great place to ask questions, to get help, to interact with other Eighth Wall developers, and also share what you've created. So with that, I'm going to be turning things over to Rigel. He's going to jump right into today's main topic, which is building WebAR experiences with animations. So Rigel, over to you.
Great, thanks, Tony. Hi, everybody. So today I'm going to talk about using 3 types of animations in your Eighth Wall projects. And we're going to be using A-Frame today. So, and I'll be pointing to a lot of different resources that most of which, can be linked to, from our project library. So, and then of course, at the end, if you have any questions, be thinking about those because we'll have a Q&A session. So with that, I will start with sharing my screen. All right, so the first style of animation I want to talk about is the animation component. So if you're familiar with lerping or tweening or any other of these words that sound completely made up, they're all sort of the same kind of sense of taking something that's a value, let's say, a position, and then over time, every frame, it's going to be incrementally moving to a different position, right? So we see this all the time. It's, in really any kind of style of animation. So keyframe animation is another, way of kind of putting this if you're setting particular keyframes over a timeline. So A-Frame has an animation system built into it that I'll be referring to as the animation component. And it allows you to do some pretty powerful things. So first, it allows you to animate any value in A-Frame. And so this means you can take things like scale, position, rotation, and you can animate those over time. So in this example, I have over here on the right, our tap to place ground. Every time I tap, we're going to grow a new cactus, and you're going to notice how it kind of pops into place whenever I tap. That pop is actually an animation over here. So we can kind of see what this looks like. We have when we tap the ground, all of these different things are going to happen. We're going to create a cactus, but then down here, what I want to draw your attention to is after the model has loaded, then we're going to animate the model. We're going to animate its scale value to a random scale. So we're generating a random number, and then we're having it scale to that point over 800 milliseconds. And so this is sort of the breakdown of like how the animation component works. It requires a property. So like I said, this can be a transform. It can also be something like a color or even another variable in your code somewhere, like a custom variable that you just want to have an opportunity to animate its value over time. And so, so there's a lot of really interesting things that you can do with that. But most commonly, at least to get started, animating transforms in this way is very useful, and it's a great way to take something like this cactus that previously I could have tapped and then it could have just appeared suddenly, but it really adds a lot of life when it springs into place, right? And the other thing I want to talk about is that springing motion. So the fact that it looks like that, it kind of bounces in and kind of shimmers for a moment, that has to do with something called easing. And so you can see over here, we've called this easing ease out elastic. And if you actually go into the A-frame documentation and you look through the properties for this component, you can see there's an entire easing section. So it might be kind of hard to read. I'll pull this up. But basically here, what we're looking at is a bunch of different ways of easing an animation in. So linear is kind of what you'd expect. It would be a straight line, right? Over time, it doesn't change. So it would look like, if you hit, go like, whoop, whoop, and there wouldn't be any kind of acceleration or deceleration. Elastic does that thing where it's like, it'll kind of, it'll start a little out of bounds and then it'll kind of come back in place and then, kind of settle itself, which gives it that really cartoonish kind of feeling. But they also have, the more traditional ease in, ease out quadratic and, others that you might be more familiar with if you're coming from like an animation background where something kind of smoothly comes in or smoothly accelerates out. So definitely play with those easings. It adds, if you're sort of choosing things that aren't linear for the most part, I found that it adds a lot of production value to, whatever it is you're trying to convey. So with the cartoon aesthetic here, I chose the ease out elastic to really give it that feeling. And so, there's other things in here that are really helpful. So there are events that fire whenever an animation begins and ends. And so you can tie, logic within your scene to the moment that one of these animation loops complete. So that's really helpful. If it's like, okay, you want to place the cactus, instead of using timeouts and things which can get really out of hand quickly, you're waiting to do the next thing until after the cactus animation has completed itself. So definitely lean into events. And I mentioned before being able to do things like animating color, and that's really great for things like opacity. So if you have a material that you want to animate its opacity over time, you can have things fade in or fade out. And again, it adds that extra level of production value, and it really makes it feel more complete and less like a tech demo or something. And so that extra level of polish, it really goes a long way. And in the moment, like whenever you get used to using this, you just sort of automatically include these things like the easings and, and animating different properties over time. And it's not just that you can animate different ones, you can actually animate multiple properties simultaneously. And so that's kind of what this looks like. If whenever you're specifying your animation component, you do this double underscore and then some kind of variable name, and you can call this anything afterwards. It's basically creating another like an additional instance. So you can animate, like in this case, position separately from rotation, separately from color. But then whenever, on a net, whenever the object is added and the animation component runs, they all run simultaneously. And so, so that's how you can kind of stack animations. So I have a few different examples of this. So here I was showing you our tap to place ground example, which is a great way to understand the sort of basic idea of this. And imagine we're animating rotation, we're animating the colors, and we're making it spin or bounce when it appears. Fireworks is another great one where, as you see here, as I'm tapping, it's doing the same sort of effect that the cactus is doing. But then whenever I hit the button to fire all the fireworks, we're doing several different animations, right? We're animating the position of the wick as the sparkles as it kind of like moves up into the base of the rocket, and then finally that rocket is slowly accelerating upwards. And so we can kind of see what that looks like here when I look at animation. So the animation wick up, I'm changing its position property to the wick end position. So wick end position is going to be whatever that transform is here, which is, I'm calculating it from the bottom of my rocket object. And then it's going to take 1500 milliseconds, so 1.5 seconds, for it to make that journey to that point. And then it's linear by default, so I didn't specify an easing there. And then next we have the fly animation. And that we're just going to set it to be 1.3 units above the ground, and that's going to take 3,000 milliseconds to get there. And then it has an end position that you can see here also, that the animation up property is taking. So so you can see kind of how you can stack all these. Another thing that I wanted to mention is you notice how in this video it all happens in this particular sequence. That's because I'm using set timeouts to ensure that they all, the animations trigger at the right moment after they've been completed. So anyway, so that's like another example of how that would work. This one isn't doing much. It's but it is there is a part at the beginning where whenever you scan the image target, that image target event triggers an animation that has the tree grow out of the ground. And so again, be thinking about those kinds of like transitions in AR because they're really impactful. Here's another one. It's a similar sort of thing. You scan the image target and then we grow all these pumpkins out of the ground in front of the image target's detected position. The portal, kind of classic, you tap on the ground and then the portal will animate open. And then this one's using a lot of different kinds of animations to get things to spin, like the portal spinning whenever you walk in. That's just looping, right, over and over again, that spin animation. And then this one's a fun one. So, here's one where I actually just set animation event inside of the HTML, and I don't think I even have a JavaScript component for this. So you can kind of see how this would work. But so basically what's going on here is I have multiple face meshes that are being animated in a circle as well as they're being animated vertically. And then what happens is whenever one of the animations that pushes the face like below where you can see on the screen, the moment it hits its position above the screen, then that's when it begins like looping itself back to the bottom. So you can kind of create these different loops, and again, all just through the HTML without any really advanced logic. And so again, that's kind of the power of the animation component. And this will come up later as I go over the other animation styles. But yeah, that's definitely like going to be like the most common one you'll start with using whenever you begin using A-Frame or Three.js or any of these other WebGL frameworks. So next we have the animation mixer component. So the animation component that I was just going over, that's actually built into A-Frame, so you don't need to bring anything in. However, with the next two components, you will need to bring them in or register them with their source code. So for the animation mixer component, if we actually look in my head.html of this project, where I have a lot of demos, you can see I'm bringing in A-Frame extras. And this is coming down from Eighthwall's CDN. So if you look at any of the projects that use this and you clone them, it's going to include that line. So you don't have to worry about it if you're cloning from one, but just make sure that you have it because the animation mixer component is housed inside of this A-Frame extras library. So, so what is the animation mixer component? Well, it allows you to handle playback of animation clips that are embedded in your 3D models that you import. So this means, if I go over here, you can kind of see with this robot model, he has all these different animation clips that are listed here. So if I click dance, it begins playing back this dance animation on a loop. He's got an idle, he's got a jump. There's these different walking, running is great. So, how do we access these, right? Well, in the GLTF file, all of these are encoded as animation clips. And then the animation mixer, similar to what's going on this model viewer, is going to parse through that file and it's going to pull out and play back those animation clips on your model. And so this is very common with character models because you might have like a series of different clips just like this. And then whenever you're playing your game or your experience, and you want to be able to have the character do what you want when you want. So you want to have them run around and similar to this project here. So whenever we're moving the joystick, he's running, he's in the run animation. And then whenever we stop, he'll revert to the idle animation. But it's more than that, because you also want to be able to blend between the animation states. And this component allows you to do that too. So, so the character doesn't look jarring. It doesn't look like, in order to jump, you have to stop running and to do that, right? You can blend the two. And this kind of gives you, this model viewer gives you kind of a sense of what that's like. So, I can click running, and then I can click jump. And then now it's actually blending the two animations together simultaneously. It might look a little weird here because we're not doing it in a sequential way. But you can imagine it's like your character's running, you hit the jump button, and then you wouldn't want it to just sort of start doing this in place, right? While your character's still moving forward, it would seem weird. So, so that's why you kind of want to blend the two together to make it look really natural. Here is the A-Frame Extras GitHub. So this is linked from any of the projects that use the animation mixer component. We have a link in there that'll show you how to get to this GitHub repo. And this is where it has all of the parameters to help you understand what this can do, right? And so, we've got clips, so the name of the clip that you want to play back, duration. So if you have a very long single animation clip and you want only for the beginning, you want to kind of trim where it stops, the playback point, you can do that through this parameter. Crossfade duration. That's really important when it comes to transitioning between animation states. And the longer the crossfade duration, the more time that the clips will be overlapped whenever they're transitioning between the two of them. Loop. So this is really helpful whenever you're doing things like the running or the jumping, where as long as you have that input applied, you just want it to continue to seamlessly loop that animation over and over again. Timescale is cool. So timescale it starts at 1. 1 is normal speed. 2 would be twice the playback speed, and then 0.5 would be half. So you can do things like slow motion, fast motion. But if you combine this with the animation component I was talking about earlier, all of these can be modified themselves through animation. So you can imagine maybe accelerating the playback speed. So he's like, maybe he starts running a little slowly and then he wants to pick up speed. You can do that by animating the timescale value here using the animation component I went over before. And then the other thing that's really cool is these animation events. So similar to the animation component, having events that you're tying your logic to is super useful for knowing when certain actions should be taking place. So so a few examples of this, we've got the animation mixer project on the project library. This is a really great, straightforward way of explaining how the animation mixer works. And then we also have on the playground one that's very similar, but it includes use cases for looping animations and replaying animations after they've completed. So if I pull back my my example over here, I can show you what that looks like. So if I grab mixer replay, save and build. So here we've got a character, he's doing this dance. And then you'll notice that like when the dance is complete, instead of just looping and continuing, it's frozen, right? We've frozen playback. And then it fired an event, which is, animation complete, which allowed my replay animation button state to become active. So if I hit that button again, it's just it's gonna keep playing it back. But this is a great example. Again, this is the animation mixer replay. This is a great example of showing you how you can control the playback, right? So here's next animation. It's like different dances. Here's the chicken dance. And then every time I hit this button, you'll notice it sort of cleanly transitions between those states, kind of smoothly finding where it needs to be. And so, and this is a pretty low crossfade duration. So if you increase the crossfade duration, it'd be even smoother, and you'd see even more of both of them at the same time. So yeah, so that's another great resource there on the playground. We also have this, which is a pretty cool project. If you didn't see this over the holidays, we have a new playground project called Character Camera, and it employs a lot of different techniques with regards to animation, being able to tap on the ground, and then the character is like moving to that over time. But also it has plenty of animation mixer use cases here. So, inside our components, so here it's controlling the animation states by depending on when the character is in motion and when they've reached their destination. If you tap on the character, it would begin playing back its dancing. I think it's called, there's the motion pose. Yeah. And then also I forgot, so this one's also using the animation component. It's scaling the ring whenever you tap, and then it's scaling away. So again, these like little subtle additions that really add a lot. And then yeah, so that one's a lot of fun. Definitely check out the Character Camera project. And then I kind of went over joystick movement a little bit. I'm going to go over the last one, and then I can kind of share a couple projects that I've made that kind of combine a lot of these concepts. So the last animation type that I'm going to go over today is called Morph Targets, also known as blend shapes. So Morph Targets are really interesting because, so unlike keyframe animations or animation clips, they instead they rely on this idea of like, you can kind of go into your 3D modeling software like Blender or Maya, and you can set a transform on an object. So imagine it's most commonly used for like facial expressions and face animations, but you can imagine something like a door on a car, and it's closed. And so you set that at the 0 point of your blend shape or your morph target. And then you open the car door on its hinge all the way. And then you say, that's the 1 of my blend shape. And so now that you've baked that, software like A-Frame using this morph target component can now allow you to say, all right, I want my morph target called car door to be set at 0.5, and then it would be halfway open. And you can animate these things over time. So now the car door, instead of being an animation that you have to actually, in A-Frame modify its rotation of the pivot point of the hinge, right? It's like now you can just simply set the morph target amount to be anywhere between 0 and 1. And then now you can use the animation component in tandem to animate the car door opening and closing. And that's really helpful because imagine if you tried to do that using animation clips, right? Well, now if you had to have an animation clip for each car door independently, then now you're blending animation clips simultaneously for one object, and that can get really messy. And you want them all to be part of the same object. You don't have to break it out into different ones. So something like blend shapes come in really handy because now all you have to do is just animate the blend shape value to be different depending on what door you want to open or close. And it doesn't affect any other part of the car, right? So, so down here, I'll show you, so with this robot, I can modify these 3 blend shapes. So this says angry, surprised, and sad. So if I move surprised to 1, you can see this is maximum surprise. And then if you move it back down to 0, he's like back in his kind of default state. Angry, I can push that up to 1. You can see he's mad now. And then sad, I can do the same thing. But then where it gets really interesting is, whenever you start combining at different levels, these different values, right? So you can start creating, you can even see here, there's very little, to work with from an animation perspective, but you can start to see how you can create emotion just through these different combinations of values. And that's like a really powerful tool that animators have access to with blend shapes or morph targets, as Blender calls them. Here's a more complicated example. So you might be familiar with Ready Player Me. So if you export a Ready Player Me avatar, they have a very impressive, list of morph targets that come with that GLB file. So I have things like jaw open, jaw mouth close. I can do eye squint left. I can do eye blink right. And then, you can do any combination of these things, right? And so it can get pretty wacky whenever you just start like messing with them like this. But the idea is that you're using, man, I'm not making myself look good here. The idea is that, you would use something like like a face effect software that like 8thWall offers, for instance, or any other kind of tracking software. And then it can be the thing that's driving all of these blend shape values. Or alternatively, right, you could have, gone in and done motion capture, facial motion capture, and then remap the captured animations to these different blend shapes and morph targets. And so, so that's another really cool way of being able to bring to life, faces. So that's why blend shapes are most often used for that. But like I said, you can use them for a lot of different things. At the bottom here, I wanted to call out, so these are called things like mouth closed, jaw open. That's more similar to like the ARKit style of blend shape remapping. But at the bottom, they have these things called visame or visame. And these correspond to sounds that your mouth makes whenever you make certain sounds. So here's a p sound, like 2 P's, an F sound. So there's other software out there. I think Oculus actually offers this, where it's picking up the speech that you're saying online to your friends, and then it's mapping that to text. And then once it has that text, then it can make determinations based off of that, what sounds you're making with your mouth. And then that's how this can then map that to the morph targets. And then now your mouth can, in your avatar can mirror the sounds that your mouth is making, the shapes that your mouth is making based off the sounds. And anyway, there's a lot of really cool stuff that you can do with these things. Kind of going down a rabbit hole with that one. But, so additionally, you can, like I said, you can combine the morph targets with the animation mixer, with the animation component, and like, what does that look like? So our morph target example is actually on our project library. And what this is doing is, we have a looping idle animation, and we're looping through that surprised morph target, blend shape, the surprised morph target as it's like becoming more surprised, less surprised. We're just sort of oscillating through that. That's what the eyebrows raising and lowering is. And then whenever you hold our finger down on the character, it transitions to a different animation state for the whole character while retaining that morph target looping animation. So that is this one. And I'll pull up the code here. So, okay, cool. So I changed it so that like now whenever you pick him up, he's waving at you, and then, but he's always kind of transitioning into this like angry pose. He's like, I don't like getting picked up, even though I like waving back. So here we can kind of see what that looks like. We have our morph target. So this is the GLTF morph component, which again is an external component that comes from this repo. So this is from Elbobo. He's got this really awesome component that lets you just blend between the blend shapes, and it's really straightforward to use. You basically you have to know what the name of the blend shape is. So this is like eye wide left. So you type that in as the value, and then you just set between 0 and 1 what you want that value to be, and that's how you end up with something like this. But importantly, right, we have an animation component that we're using to modify the value of our GLTF morph component to be between 0 and 1. We want it to loop, and then we want it to ease in and out. So again, kind of combining all of what we've learned between animation component in Morph Targets, you can create these smoothly animated, Morph Target animations. So that's a really great way to kind of combine these two things. You'll also notice we're using the animation mixer, and we're specifying we want the idle clip. But then whenever I pick them up, this is the event that is saying, like, whenever we want to start dragging the character around, that's when we set attribute the animation mixer component to be wave. So it'll override the one that we had set in our HTML. And then whenever I drop him, it'll transition cleanly because we're using that crossfade duration parameter. And so I can do this all the time, and it'll never look weird. It'll never look jumpy. It'll always be kind of smooth. Trying to figure out where the beginning and end points of that animation is, and sort of intelligently navigating between those two clips. So yeah, and then I had one last kind of fun one I did. So this is I was just kind of playing with this last night. Oh wait, that's not it. Mixer whale. So I found this really cool whale on Sketchfab, and it comes with an animation clip. And so I dropped this guy into our project that uses the joystick. And so now you can kind of fly your whale around the room with the joystick. And it just looks cool having this like animated whale. And I know this has been done before in AR, but I just, there's just something really cool about seeing a whale kind of flying around your room. And you're, again, using the joystick animation, or sorry, the joystick logic, we're translating his position across the ground, which itself is an animation. So it's similar to that of to the animation component. I don't think it's actually using the animation component to do this, but it is an example of combining different animation types. So anyway, just wanted to show that. And with that, we have gone over those three kinds of animations. Yeah, if you have any questions, feel free to ask away in the Q&A. Thanks.